let me introduce the first speaker, who is Foteini Valeonti. She works for the Sloane Lab, and Foteini is going to be presenting about the decentralizing digital humanities. Foteini Valeonti is a research fellow at UCL, working at the Sloane Lab. She specializes on the intersection of blockchain technology and culture. And she was named a cryptocurrency philanthropist in 2023. She is a research fellow at UCL and curator of Regen. You can go to regencurates.org, who is a curatorial initiative that has raised over £500,000 for charities in the UK and the US. So Foteini, when you're ready, please start sharing your screen and welcome.
Hello, everyone. Good to be here. Javier, thank you for the invitation. Okay, so this is the first time. Welcome to all. This is a right. So this is a special study that we did at the Sloane Lab, which concerns my area of expertise, but I didn't deal at the core with what we do at Sloane Lab. However, just so that everyone is aware, the Sloane Lab, looking back to build future shared collections, is a collaboration between the UCL, TU Darmstadt, the BM, and the Natural History Museum. But it is also in partnership with numerous other organizations, such as the Down County Museum, the National Galleries of Scotland, the British Library, and others. And essentially, the goal of our project is to reunite the collections of Sir Hans Sloane. The Sloane collections was essentially the founding collection of the original British Museum, which when it was divided to the present day BM, BL, and the Natural History Museum, his collection was dispersed across numerous different organizations. So this is quite a challenge now that we seek to address. The Sloane collection ranges from fossils, vegetable substances, to music instruments and printed books. He had a vast collections of all sorts. So it was also, it's not a coherent collection that we are dealing with. And the technical work we've undertaken at the Sloane Lab includes data aggregation, actual digitization, data mobilization, as we did here for the marginalia around the annotated copy of Sloane of Res Historia Plantarum, data modeling, semantic unification, and as well as the development of methodological instruments for navigating such a complex data environment, the Data Atlas, which is the other output that I've been leading at the Sloane Lab. Today we will be talking about this special study that was inspired. The focus has been, to see how blockchain technology can essentially benefit the Sloane Lab and TaNC more broadly. It is titled Decentralizing Digital Humanities, Exploring Blockchain Technology and Web3 for the Sloane Lab and TaNC. And it is about to be submitted now. And this is the first time I'm presenting it, so good luck to me. So first of all, what is a blockchain? By definition, it is a distributed immutable ledger that is maintained and verified among a network of peers. And in simple terms, what that means is that it is a commonly shared database where we all have access to, we can all read, we can all write, but nobody can compromise it. No one can vandalize it, no one can defraud it in any way. And why all the fuss about blockchains? Essentially, the innovation behind blockchain was that it enabled trustless transactions between complete strangers without any trusted intermediary being involved. That's why they're called kind of trustless. So Bob could send, with a blockchain for the first time, with blockchain, Bob could send money to Alice without the oversight of any centralized authority, without knowing Alice, without trusting Alice. And by removing the need for trusted intermediaries, blockchain was pretty much the first technology that made true decentralization possible. And whereas the first blockchain, Bitcoin, was focused on financial transactions and still is, then came Ethereum and Vitalik Buterin, who's one of the big pioneers of the space, the founder of Ethereum, that implemented smart contracts. If we look up the term smart contracts, it goes back to the 90s. And the blockchain as well already used technology, previous inventions. They kind of all bring them together and evolve them slightly. But it's not that, that all came, that all has happened after 2008. This is research that goes back to the 90s. So Ethereum was the first blockchain that implemented smart contracts, which are essentially autonomous software programs that operate on the blockchain. So that's why they're called smart contracts, because they're contracts that can be self-executed. But they are pretty much programs that can do all sorts of computations. And that fostered the development of the so-called dApps, decentralized applications, and the advent of this new form of internet that is based on decentralization, which we refer to as Web3. And I mean, it struck me that although internet is quite central in digital humanities, when I started doing this research, Web3 was not examined at all, wasn't like being considered, or blockchains, very little. So in this study, we identify 4 challenges that are faced by digital humanities infrastructures, but digital humanities projects also more broadly, where Web3 could potentially be of benefit, assessing also obviously associated risks. We also identify areas which are core to DH, where we should not expect Web3 to make any impact, okay, in the short term, in the medium term, if not the long term. And the first one is digitization, because digitization requires, particular machinery, and Ethereum and blockchain networks are pretty much networks of computers like ours. And data analysis, because computation is very expensive in a decentralized environment. So data analysis is quite prohibitive, at least today. Now, I will start with the main findings as a disclaimer, okay? Web3, at least in the context of digital humanities and for the benefit of digital humanities, is largely work in progress. For digital humanities, few solutions are immediately deployable and directly usable, okay? And if we want to really reap the benefits of Web3, highly specialized, there should be, highly specialized expertise, not just technical expertise, blockchain-related expertise, it's a nature in and of itself. Another type of engineering, a different type of apps. However, there is significant potential in this field for DH, for digital humanities. So I think it is important that we start to familiarize ourselves, we start to understand this world so that we are able to monitor the field, and when technology matures, we are able to make the most of it. Now, which are kind of like the challenges we identified? The first one is data storage, which is very expensive now and it is over-centralized. The second area is persistent identification. The third is data permanence. How do we maintain outputs post-grant? What happens after September, when the Sloane Lab ends, for example? And then interoperability beyond Web 2.0 on to Web 3. Today, we will touch upon 2 of those because we don't have that much time, which is data storage and data permanence. Now, right now, data storage can be characterized by very high costs and over-centralization. Cloud storage is considered, and hosting is considered the industry standard. Also at the Sloane Lab, we use Amazon Web Services. Because obviously cloud storage, when it came up, and those of us old enough, we remember, it had unmatched benefits in terms of primarily scalability and also flexibility. And now it has evolved to have, as long as you have the money to pay, you can have all sorts of resources at hand. Even at Sloane Lab, we also use Extract. We use those free tools that come up with, not free, we've used those tools that come readily available by cloud providers. However, cloud hosting can be prohibitively expensive, and in DH that it matters, for small projects in particular. And then centralization is worsening. So this figure is actually the trend is upwards. It's trending upwards. Okay, so over 60% of all websites that use cloud computing today, I don't know any serious website which doesn't use cloud computing, are served by 3 American companies. 60% of internet traffic goes through Amazon. 60% of websites pretty much is either Amazon or Azure or Google Cloud. And this comes with with several downsides. And if it's not that, I actually don't like that, as an idea that 3 and 4 websites are hosted, or 6% of websites are hosted by 3 American companies. It also has technical problems, like in 2021. There's an infrastructure provider named Fastly that is used by all cloud computing providers. It had an unexplained configuration error which brought down Gov.uk, other government websites. It brought down the BBC, as well as major commercial websites for nearly 1 hour. And this is just one outage. But that is to show, even if we don't have ethical second thoughts about centralization, it also has technical, it is a bottleneck, it is a weakness. Now, Web3 takes a fundamentally different approach to storage. And its storage infrastructure could be considered what is called the Interplanetary File System, IPFS. There are several different decentralized storage providers, but IPFS is the undisputed leader and can be considered the backbone of Web3. So IPFS can be described as a versioned decentralized storage system which uses content addressing. So it is versioned, so files are being versioned, and it is decentralized, it is peer-to-peer, and it uses content addressing. It doesn't use kind of arbitrary URLs. The IDs, the content IDs, are pretty much a variation of their file hash. That's why it is also fertile ground for persistent identification. It can borrow itself to good, interesting uses for persistent identification, which will be covered in the paper and not today. IPFS is an open source project with over 4,000 contributors. It was invented by the founder of Protocol Labs, Julian Bennett, which is in itself an open source laboratory. They described themselves in 2014. And Julian Bennett, argues that IPFS pretty much evolves and connects proven techniques from previous peer-to-peer systems. So what he did is he saw what BitTorrent had done, how it worked, what Git did, and how it works, and then it kind of combined those proven technologies into a single cohesive system. IPFS, we must clarify, and it now stores petabytes of data, enormous amounts of data. IPFS is not a blockchain, it must be clarified. That's why we talk about Web3. Web3, not all technologies are blockchain-based, but they are blockchain-related. Instead, it is a peer-to-peer storage system, such as BitTorrent. And blockchain networks, there are, however, blockchain networks that serve as incentive layers on top of IPFS. And what they do, they pretty much help to manage storage deals, how I'm buying storage, for how long the storage will be. It's kind of like the marketplace for using that the IPFS storage. And the prominent incentive layers for IPFS are Filecoin and Crust. And Filecoin is also run by Protocol Labs. So how could one use IPFS if someone wanted to to play around with it? As in any peer-to-peer system, and those of us who had used, were downloading torrents back in the day, you just download an easy-to-use computer app on your computer, and then you can upload and store files there for free. Okay, these will be automatically addressed, and these will be automatically federated. However, permanence is not guaranteed. And if my computer shuts down or if I shut down this particular application, my file will still be live for like a few hours, but then it's gonna be deleted eventually. And also, if many people try to access my file, then I will have to start, although that is free, if I want this file replicated to many different computers, then there are charges for so-called pinning, and we will come to how much it costs in a minute. And then the other catch of IPFS, which, however, should not be a concern for digital humanities and our kind of projects, files are public. So you have to use kind of custom decentralized applications that use IPFS if you wanted to kind of store your own files. But my research was not about how can I replace my, Dropbox or whatever. It was primarily, for DH. But it has to be noted that by default, all files on IPFS are public. So exploring IPFS for the Sloane Lab, the big weakness of IPFS and other decentralized storage systems is that they cannot store dynamic websites. You cannot have a backend API being, running from. That's why you kind of always need the traditional web to website still. However, it could be used to store data sets that are public and that are static. But there is research that indicates that there is potential for knowledge bases. And at the Sloane Lab, our primary output is pretty much the Sloane Lab knowledge base, a GraphDB triple store with a metafacts and a research space on top of it. Metafacts and research space are like kind of the front end looking up for the GraphDB kind of thing. There was this study, a very well-developed solution, a fully decentralized triple store managed via the Ethereum blockchain by Gro and Mahmoudi. And essentially what they did is they provide, and they also give the source code on Git, a complete technical architecture for a linked open data infrastructure that is fully decentralized using Ethereum. It uses IPFS for data storage and retrieval, and then Ethereum for naming, versioning, and then storing the metadata of those data sets. Interestingly, it even supports Spark queries. However, this is, although the code is on Git and it is fully functional, it has not been tested in deployment, and it would require technical expertise also from contributing parties. So that would be interesting to consider, to think how other IROs could have been using that. So the technical, it's quite steep. The technical barrier is quite significant in Web3 at the moment. So possibilities for decentralized thinking about centralization, for example, possibilities for decentralized storage have emerged, primarily for static data sets, but we also see that there is research and potential that could also be the case for knowledge bases in the near future. And as far as the cost is concerned, and this is a figure provided by Filecoin, so IPFS should be actually cheaper, even cheaper than that. And we will see in a minute another use case. It is over 5 times cheaper than Amazon. And but then there's also this possibility for our kinds of projects, for digital humanities projects, that for culturally significant data, storage can be provided for free. So we mentioned previously the incentive layer Filecoin. Okay, this in its own description, like what is Filecoin? They say they are a decentralized storage network designed to store humanity's most important information. Arweave, which is a different infrastructure, it's not IPFS, it has its own decentralized kind of storage and its own blockchain. but it's quite prominent. It states that it is focused on the preservation of humanity's most important data. So there's this common theme emerging across decentralized storage providers to try and make a space for hosting open data for free of charge. So although many people talk about it, Filecoin has actually implemented it. So they offer Filecoin Plus, which is quite a sophisticated incentivization program with notaries, with all sorts of kind of different parties that eventually offer a free storage for projects that have valuable to humankind, let's say, open access datasets. And this actually works. It is currently in use. And those datasets, Filecoin is storing them on the Dataset Explorer, which hosts over like 2.6 petabytes in open access datasets. Datasets such as the Encyclopedia of DNA Elements, the LibriVox audiobook collection of books in the public domain, and more. However, it's quite hard to use. Platforms keep changing. Like for me, the research has been such a challenge because what I was doing back in the summer, it may not be relevant today. And to Sloane Lab, we were offered to use that storage, but that had to go, through working directly with protocol labs. And then these files, these data sets are actually very hard to access. So it's quite funny on the Dataset Explorer, they say, retrieving your desired file is a straightforward process. And you're like, great. Depending on your preferences, you can use Boost or Lotus configuration or Lighthouse APIs. These are all kind of command line tools, like you've lost like 99.9% of users there. So there are many caveats. However, when I was doing this research and I was interviewing protocol labs quite a lot, they were very keen to help, actually. They were quite keen to make, since they have this technology for projects to use it. Now, about data permanence, what happens? So this is kind of like a big thing in research. What happens once the funding of a fixed-term research project is over? Interestingly, Web3 provides possibilities for what is called perpetual storage. And then there are these notions of the perma web, the permanent web, and so on. And incentive layers, such as Filecoin, let's say, or Crust, we'll see in a minute, blockchains that are operating on top of IPFS are able to manage long-term storage deals. So if I have a lot of money today, I can buy a storage deal for the next 100 years. And Crust is one of it uses IPFS, but it is not Filecoin. It is not operated by protocol labs. And in its use cases, it brings up Uniswap, for example, which is a very big platform, is the largest decentralized exchange. And for 81 replicas around the world, for 100 years, it costed them 1.5 ETH, less than $10,000. I don't know, they say obviously that Uniswap uses other replicas as well, because for a website as big as Uniswap, and that is to host their front end, the code of their front end. Their front end. The 88 replicas perhaps is probably not enough for Uniswap, so they also use other replicas. But still, this is a great deal that was possibly, for research projects which do not have a fraction of the traffic of Uniswap. Now, about risks and challenges, as I mentioned, this is a rapidly evolving, ever-changing landscape. So in my paper, I've written about platforms that, were discontinued a month after I was, speaking with protocol labs, and they were telling me, well, it's kind of an ever-changing landscape, making research very difficult. And permanence is not guaranteed. So IPFS also, there are disclaimers that even for such a huge network, no one will guarantee to you. There's no company behind it, So no one will guarantee to you, oh, it's going to be up there for, it's going to be on forever. And then decentralization also means no oversight, which provides fertile ground for bad actors, you know. And there's the statistic saying that 9% of global phishing threats are through IPFS. And then you're wondering, what is the other 81%? And phishing can also be found and has been found on heavily monitored servers, platforms such as the Amazon AWS. But it has to be noted that, you know, where there's no oversight, there's more room for fraudulent use. And then in the broader Web3, there are poor legal and technical safeguards because this is such a rapidly moving field, which is great because technology matures faster than it would. It means that the regulatory frameworks, the technical frameworks, they are kind of rushing to catch up. And for us, we are the Web 2.0 users. We just click and try to figure things out. And we know someone has our back. You know, if something happens, I'm going to be on a customer support and everything will be fixed for me. This is a nightmare to jump from Web 2 to Web 3. And the adoption curve is very steep. As I mentioned, it requires specialized expertise. And so to conclude with some recommendations, end user interaction, when we talk about these technologies and we're thinking of, you know, experimenting and exploring them and perhaps even using them to a small scale, in no way should end user interaction invite users to use, you know, Web3. It should be Web 2.0 like fetching a file, like doing things they're used to, they know how to do. We shouldn't make, in this instance, be making any decentralized application that invites our users to create a wallet in order. And if we are to do it, we have to be super, super, super careful. Again, we can't do it, but we have to need, as long as we use it, you know, for storage, for things like that, that really do not affect the end user, I think this is a better playground right now. But we should be monitoring developments because I think there is significant potential, as I mentioned, for open data storage, and also these possibilities for perpetual storage. And then to TaNC or similar funders, I think I would encourage engagement with pioneers from this space. So Protocol Labs, who invented IPFS, they invented the kind of, you know, Filecoin. They are quite keen. They like the fact I was doing research. I think one of the founders is also actually UCL alumni anyway, but you know, they are keen for that knowledge exchange, and engaging with them would also help steer developments so that they are beneficial and relevant for digital humanities and for research infrastructures. So they are very open, and I think they would welcome that. So that was it. Thank you very much. I hope I wasn't over. Right.
Thank you, Foteini. Yeah, amazing. Yeah, I already have a lot of questions, but again, we'll leave them for the end of the talk. So next, from the Sloane Lab, we have from Congruence Engine. So Foteini is in the Sloane Lab, Ana Maria is in Congruence Engine. So Ana Maria works at the University of London, and she's going to be presenting from collections data to responsible data, data-driven approaches and ethics in digital culture heritage. Ana Maria Sichani is a postdoctoral research associate in digital humanities. She's based at the Digital Humanities Research Hub, School of Advanced Studies at University of London, and she works for the Congruence Engine project. Her main research interests include computational archival sciences, digital cultural heritage, and research infrastructures, and digital pedagogy. So Ana Maria, thank you very much for joining us. So whenever you're ready, please feel free to start sharing your screen.
Yes, many thanks, Javier, for the introduction. Many thanks to the TaNC program team for inviting me and for hosting me today in this seminar series. You know, it's fascinating to share this webinar with Foteini and looking forward also to the discussion. I feel that we are like, you know, discussing the two ends of the information spectrum, and it would be really interesting and fascinating. So let me start with a brief overview of my, oops, okay, of my webinar. So I'm going to introduce the Congruence Engine project and the social machine as infrastructure concept that we developed, and frame this through a collection as data approach. Then I'm going to briefly present our responsible data working commitments. And for the rest of the webinar, I'm going to present a couple of data-related investigations I've conducted, starting with museums' online catalogs as data assessment, the positionality-aware framework for data and AI-driven cultural heritage pipelines, the generative AI, data protection, and intellectual property in digital cultural heritage. And I'm going to conclude with some thoughts on how we can move from responsible data to sustainable data. So, fueled by action research methodology and interdisciplinary collaboration, and through a series of data-driven pipelines, the Congruence Engine project conceptualized the national collection as a social machine that facilitates collaboration between people, data, and machines in order to experiment with innovative digital methods and convert industrial history collections to machine-readable, structure, and connectable digital data. So from the outset, this conceptualization enabled us to understand the social and the technical infrastructure of the social machine, that is humans and machines, to be inseparable in an equal, creative, and dynamic relationship, working together in making cultural heritage data better connected and interoperable through a dynamic process of datification, annotation, and connection. For my work in Congruence Engine, I focused on issues around the data-related infrastructure of the national collection as a social machine by adopting a collection as data approach. The collections as data, it's a concept, a community of practice, an area of practice, inaugurated back in 2016 in the United States, and now it's in full development across the globe. It focuses on responsible development and computational use of digitized and born digital cultural heritage collections, as well as digital information about collections, such as metadata, software code, reports, and other forms of documentation, by making these collections available as data amenable to computation. By placing collections as data at the core of our data-related processes, not only we connect our work to this broad and vivid community of practice in the GLAM sector, but we also reposition the concept and the practices of responsible data and data ethics at an infrastructural level. And that was a crucial decision for us. So such a choice is a crucial for the Congruence Engine, and I would argue for research infrastructure, cultural heritage research infrastructure in general, as it enhances the design, research, and development of a national collection through 4 directions. So it allows us to experiment with research-driven computational linkers among collections, but also beyond with other information sources such as Wikidata, to explore advanced search and access pathways to collections, to activate participatory modes for data enhancement and engagement, and to define data-related infrastructure requirements. Since the very beginning of the project, we at the Congruence Engine made 3 central working commitments around our data work. First, we adopt the concept of responsible data and responsible research as a guiding principle. So in the context of our agenda, responsible data refers not only to the identification and treatment of ethical, legal, and social aspects of cultural heritage data, but also to an integrated set of principles and processes that support and promote the value of transparency, equity, and care while we interact with cultural heritage data, with data subjects, and other stakeholders. The second commitment we made was that our work is at the same time experimental and self-reflective, in line with the action research methodology of the project. As we developed and deploy pipelines using ontologies, machine learning, computer vision, at the same time, we question the data-related frameworks and standards we found in cultural heritage data we work with, or the choices we needed to make along the way. So instead of developing a set of abstract data requirements and best practices, like as a list, we actually applied and tested them through multiple iterations and failures in our very own living professional practice throughout the project. And third, we foreground data ethics as an embedded project practice, rather than apply them as an afterthought, a box-ticking exercise, so tick, 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 yes, we've done it, or a standalone set of ethical guidelines outside our everyday research and professional work. So data ethics for us in the Congruence engine evaluate data practices with the potential to adversely impact on people or society in data collection, sharing, and reuse, and is an effortful process. It takes a lot of time and includes consistent and meaningful engagement with areas that span from data collection, curation, and reuse, the methods and the digital technologies, the frameworks that we're using, data sustainability and access, to environmental impact of data-related choices, and digital data skills literacy. And allow me a personal comment here to thank all the Congruence Engine team members, as well as Sarah Perry, Ananda Rutherford, and Katrina Foxton, my co-facilitators at the Cross Discovery Projects Research and Data Ethics Workshop we organized last January at the Wellcome Collection, because it was these collaborations that enabled me to deepen and extend my understanding on data ethics and responsible data in digital cultural heritage. So in what follows, I'm going to present a number of data-related investigations and exercises we attempted concerning different stages and aspects of the data lifecycle and cultural heritage institutions, in order to highlight mainly the heterogeneity of these challenges, as well as to offer, let's say, entry points to address them through a responsible data lens. So for data sets we ingested from project partners, as well as for data that we originally created throughout the project, we developed and established a responsible data curation and management strategy. Among other things, we structured data sets in order to facilitate informational processes, including ingestion, analysis, storage, preservation, and reuse of data, and to respect also values of transparency and openness. We also introduced and developed data documentation mechanisms that go beyond metadata, such as datasets and model cards, in ways that enhance contextualization, transparency, versioning, and reproducibility of the data, and also acknowledge the labor, support the needs, and reward all subjects involved. Alongside a high level of quality awareness towards this and other data curation mechanisms, we developed also a series of digital skills and data training events, mutual learning sessions, and digital drop-ins for team members, but also for project partners as a core project activity. By incorporating responsible digital data practices as part of our project ethos, we established an accessible way to think critically and hands-on about data practices and choices, and at the same time, we challenge in practice existing divides in digital data literacy. So shifting the focus now towards data practices in cultural heritage institutions, we first wanted to assess the status of challenges online catalogs and dataset pose for large-scale analysis and linking between different collections. So as we all know, data and GLAM data is never raw, and no data set is complete or neutral. So data collection doesn't happen in a historical or institutional vacuum. Context and politics of collection, preservation, and dissemination are always relevant, human-related, and often less accessible pieces of information within the data management and publication lifecycle. Layers of historical data documentation, legacy cataloging, and technical systems are often hidden, layered, overwritten, often lost or omitted. So not surprisingly, what we have in front of us today, in the form of online catalogs, is the top of the data iceberg, or the last chapter of a rather complicated history of documentation and cataloging, which often slips unnoticed. These legacies of cataloging practices partially explain why museums' data sets are far from a neat, perfect set of structured data, thus impeding sophisticated analysis and linking at scale. So to make these hidden layers of data visible, we experimented with some object biographies through cataloging instances, from using Science Museum group collections to map the data flow between the archival hard copy record of the object in question, in form of index cards, or the Form 100 record here from the Science Museum, and the online publication of the record, in the online catalog, or the data available through the data management system, the MIMT entry, which is the system that you use for documentation in the Science Museum for records, and the online catalog fields of the record. To demystify now the data-related practices in museum online catalogs that suspend their connectivity and advanced use from various users. I developed an assessment matrix, for museums' online catalogs as data through a combination of empirical research and landscape analysis, hopefully to be published soon. So this matrix actually assesses 4 basic functionalities that online museum catalogs are designed to offer for collections data. That is structure, access and reuse, link, and discovery and search. The matrix is influenced by the 5 stars of open data for publishing data online, developed by Tim Berners-Lee, and ranges between 1 star. So this is like the bare minimum for read-only access to data, to 5 stars for enhanced connectivity, which goes beyond catalog level. And for each of the 5-star levels of this assessment exercise, I also developed a top-level technical requirements. That's like a guiding, it's like a guiding hand for some institution that might want, or for a user that want to assess the requirements in order to achieve the start level in question. So now digging deeper into the connections here that's institutions as data, the last couple of years, there is a clear momentum for artificial intelligence in GLAM and collection as data communities, and specifically for data sets used in AI-driven pipelines, mainly as training data. Although the field is still in its infancy, now I think it's the moment for us to start developing a responsible AI landscape also for digital cultural heritage. In this direction, I designed and developed a positionality-aware framework for AI-driven pipelines used in cultural heritage. I'm going to introduce briefly also the concept of positionality for for everyone. So positionality is the culmination of an individual personal experiences or and sociocultural positions such as race, ethnicity, class, gender, nationality, sexual orientation, that somehow influence how they interact with the world. So positionality, in other words, serves as a lens through which we interpret and understand the world, and is unavoidable in every human-related activity, including information systems and infrastructures. So positionality and how it embeds itself in processes and systems produced and performed by individuals plays a significant role in the entire data lifecycle and digital cultural heritage. From the formulation of standards and the creation of tags or the ontologies, the collection and interpretation of data, to the development of data-focused AI tools such as machine learning models. So AI-driven pipelines and systems are designed by humans who inevitably bring in their own positionality. But however, positionality is often overlooked in the context of data collection, classification, annotation, and algorithm development in AI-driven pipelines. By placing the human element at the forefront of our data-driven processes, we seek to uncover how positionality enters, impacts, and embeds within data and systems in AI pipelines and cultural heritage. Through this positionality-aware framework, I seek to introduce a more human-centered, actually, perspective within the pipeline concept, and transcend also the limitations of traditional bias mitigation strategies, and foster a more transparent, responsible, and equitable landscape for AI in digital cultural heritage. So for this approach, I adapted the well-known in the responsible AI community concept of practice of card-based documentation and assessment. So the proposed AI-driven pipeline is a kind of an abstract diagram to help us uncover positionality. So AI systems are very varied and way more complex than the one represented here. So the framework is described through three different cards: people, data, and systems, and corresponding to each of three components in the pipeline structure. Each card includes a number of processes related to the corresponding pipeline component and a number of indicative questions to help uncover positionality. Of course, its pipeline and its case study and its model is unique. So there is, of course, room for adjustment here, but this could be a good starting point to functionality in AI-driven pipeline. And given there is currently a vast reservoir of digitized and born digital cultural heritage made available at for immediate use in AI and supported with digital curation that cares about transparency and ethical issue, there is nevertheless sometimes remain legal obstacles for the uptake of cultural heritage collections as data in AI. And despite comprehensive frameworks, there are comprehensive legal frameworks for digitization of cultural heritage records. There are still several legal ambiguities when it comes to the reuse and redistribution of digitized cultural heritage in AI context. And having spent, the last 20 years advocating for and supporting institutions towards opening up their collections as data, cultural heritage community witnesses the dawn of an era where corporations developing advanced AI systems are utilizing freely accessible online cultural heritage data to train their models, often without regard for copyright, intellectual property rights, and data privacy concerns. So should we reconsider our open licensing approach towards our collection? Can GLAM data be mined for training an AI commercial model without asking right holders for permission? Is the output a derivative work of the ingested copyrighted works, or it's an original work with brand new copyright? So in order to make these and many more rather difficult and obscure topics more accessible and easy to follow for cultural heritage researchers and professionals, I created a navigation guide in a toolkit format, actually, to be published soon in our project GitHub, structured under questions and points of information. So the toolkit includes definitions of AI-related concepts, an outline of the legal framework in Europe and UK as it develops, is an evolving area. Questions related to the main stages, aspects of AI systems. That's the inputs, the tool itself, and the outputs. So these are like a couple of examples from the questions on the inputs and the outputs that you can find in the toolkit. So the pace of AI, of course, continues and will continue to accelerate. And we expect that terminology, legislation, but technology as well, will around this area will quickly evolve. So this toolkit should be viewed as a snapshot in time. My intention is to keep it as a work in progress. To conclude, working closely with the cultural heritage data in its many iterations, from digital data curation choices to positionality awareness and legal frameworks around AI use, has reiterated, actually, to us the importance of responsible data as a way of ensuring sustainability for the national collections infrastructure. Through the Congruence engine project, we are developing not only innovative digital tools and approaches to access, link, and enhance cultural heritage collection and datasets. More importantly, we are assessing the frameworks to embed data ethics awareness in our data-related practices. And we are developing the capacity building mechanisms to integrate responsible data skills into our research and professional repertoires. As this phase of the Towards a National Collection program is now coming to an end, I think we should all be in a good position to discuss and starting developing how, the way how to shift from awareness to operationalization of responsible data practices, and also professionalization of under-recognized data roles and skills at an infrastructure level and at scale. Infrastructure, at the end, is about people. And I want to suggest and to conclude my webinar on that note, that investing in responsible data literacy is an infrastructural investment that will pay off in the long run by building informed and sustainable communities of practice around responsible and ethical development, curation, and reuse of cultural heritage data. Thank you very much.
Thank you, Ana Maria. Let me just remove the spotlight and go full screen. Yeah, so thank you very much to both of our speakers, Foteini and Ana Maria. So we have a few questions on the Q&A. which probably this address is more focused to you, Foteini, and the question is about the carbon footprint or the energy costs of these kind of networks. But perhaps the interesting bit will be comparing. So the type of models that we have now, is this more expensive? Is this actually a better solution once we start accessing a distributed model? So what is your perception of or your understanding, or what can you illustrate us more into the energy aspect?
Yeah, I mean, thank you for the question. First of all, if one was to use just IPFS, it would be like using like BitTorrent. So there isn't any blockchain involved. Then if we were to use a solution where a blockchain is involved, unless it is Bitcoin, and as I mentioned, Bitcoin is primarily used for financial transactions, so there's no dApps are not really a thing on Bitcoin. Bitcoin cannot really support decentralized applications. Virtually any other blockchain, at least from the major blockchains, is proof of stake. So the reason there was this uses a proof of stake consensus mechanism, which is comparable to standard computing. The big environmental debate on blockchains stems from the fact that Bitcoin is very bad for the planet. I mean, the carbon footprint is substantial. It's twice the size of the carbon footprint of YouTube. Okay, so it is big. But the debate for Web3 was because Ethereum was also proof of work, had this very energy intensive consensus mechanism. However, Ethereum, it was back in September of 2022, it transitioned from proof of work to proof of stake successfully. So the debate about the environmental impact of, for example, an example of dApps, and it was, for example, NFTs, that kind of faded out. It was considered like the event is called the merge, where Ethereum transitioned from proof of work to proof of stake, and became energy efficient in a way. It is comparable to other, the other servers that we're using. So for Web3 in particular, because all blockchain and the blockchains that I'm dealing with, we talk about in the paper, are all proof of stake. I think this argument applies it can only apply for Bitcoin. And if we look up, for example, the merge or how, the transition of Ethereum and all that, we will see that also, in the mainstream media, it was acknowledged that, now blockchains are becoming energy efficient, environmentally friendly, or, yeah. That answers the question.
Yeah, thank you.
Can I just make a quick comment on this? Yeah, I mean, that's, it's really, really interesting, because we are also exploring, let's say, the environmental impact of computationally intensive work, such as AI mainly. We're not dealing with blockchain as Foteini's field. But like with AI and big data, it's something that interests us in the Congruence engine when with my two colleagues, TaNC Kitcher and Max Log, we are conducting and environmental impact exercise. So I think that is really interesting to, to assess, not only the environmental impact of these maximal computing exercises and, let's say, delete all the work that has been done and will be, just exclude them from our, repertoire because they're really energy hungry and all this stuff. But I think it's really important, for us to work in a different way and explore alternative ways to work with these technologies in an energy efficient way. So, for example, the idea of try and work with pre-trained models or create, let's say, libraries of, well-trained models in cultural heritage with data sets that they are good enough. So, this is an approach that will, will save, let's say, energy from, let's say, training that is not necessary. So I think that it's, it's really interesting, how the field is actually evolving towards solutions that would address this high energy consumption of this type of work.
Perfect. Thank you. There's another question in the Q&A, but before we go to that one, I have a question, and that's open for both of you, and probably a little bit more for you, Foteini, and it's about the care principles and indigenous rights and the benefits of these blockchain technologies. So especially I was wondering if you could elaborate a little bit more on, for example, how, for example, it can enable authority control, and that collective benefit. So enabling those tools for the authority control, and particularly that ethics and how they can facilitate smart contracts and this, I mean, the authority control mainly for indigenous rights and this type of smart contracts. So if you can contextualize or perhaps expand in terms of indigenous rights and care principles in particular.
The good thing is, the good thing is about blockchains is that they are open for everyone to read. Okay, so there is no, whatever happens is visible on the blockchain. Financial transactions, other transactions. So if I collect crypto artworks, everything is visible on the blockchain. No one can hide it. So I think this transparency and the inherent, and that because capability of blockchains for provenance are essentially, are very suitable for giving credit where it's due. And perhaps transparency more than anything, so that people are aware where the data is traveling, where is it being used. And so, yeah, that would be my immediate thoughts on that. Yeah.
All right, thank you. Anna Maria, would you like to step in?
Can I ask actually a question to Foteini? Super. Yeah, I was really interested in that point that you made, Foteini, about the the remove of the point that the IPFS, sorry, kind of remove the need of transit intermediate, and actually the blockchain, remove the need of transit intermediaries, among the transactions, let's say. And I was wondering, how do you see this particular point to be addressed? I don't know. I am a bit concerned because, especially digital humanities and cultural heritage fields are communities that are kind of built on trust. This idea of that we are creating, or that we are creating collections, or that people are actually giving collections to cultural institutions because they are they're good on respecting them and caring them and preserving them. So I was wondering, what are in your opinion, the mechanisms or the ways that we can address this this point for digital humanities communities?
Yeah, I mean, yeah, funny enough, my PI, Julian, didn't like the word trustless. She's like, what's that? And I'm like, that's how, that's the definition. It allows trustless transactions not requiring trust. It's like, I don't like it, take it out. And so, and it's right. I mean, for me, it took like a second and third and fourth time to process what that means. But so I can understand why Julian was wise in order to insist to remove that, because it conveys the wrong message, apparently. But essentially, that means that we're all grown-ups and we can all decide for ourselves. Okay, and if I want to transact with you, nobody else should necessarily, we shouldn't, we are grown-ups and we can manage it by ourselves, and technology can help us, against fraudulent use. Now, for community projects, database blockchains, are particularly suitable because, fundamentally, as mentioned earlier on in the presentation, blockchains are commonly shared databases. So if collections decide to use them, then, as mentioned, through provenance, they will be able to see where and how their collection is being used, and provenance is quite thorough. And as mentioned, anything that happens and is being registered on the blockchain, is transparent for everyone to see and use. But I think for communal projects, I think both blockchains and also decentralized storage systems such as IPFS, which is not a blockchain in and of itself, are particularly suitable, and that's why I think there's significant potential in digital humanities. But I mean, the technical curve is still very steep to embrace them and, to use them properly. Because, for example, they are decentralized and, we can do those great things. But that takes as a requirement for me to be familiar enough, for you to be familiar enough. And yes, the lack of safeguards is legal safeguards, technical, especially as mentioned, coming from Web 2, where I'm just clicking. It's a big gap. So yeah, I'm not saying there's this. As I mentioned, there are a lot of risks and challenges associated with proper use and making the most of it. Yeah. Good question.
Perfect. You probably noticed also on the Q&A, we have a question which probably is more addressed for you, Ana Maria. So the question reads, surely GLAM inventories create database right when they combine data with different IP sources and as a result create new IP provided. This passes the fair use test and that can be published under open license. So any thoughts?
Yes, just a disclaimer. I'm not a legal expert. I'm just, exploring the area from a researcher's point of view. I'm collaborating with a legal expert on this matter because as I said, also it's a really, it's an area that is developing. So it's, there are a number of things that are happening in the cultural heritage field at the moment. So yes, it's true that the database rights, it's something that it's there for any new entry, and we can create also data with different IP sources, and that's create new IP. But if I get to the core of the question, I think that is also kind of relates to the AI use of data. So things are quite different there because of the technology that's behind the, let's say, foundational models. So the foundational model uses data to train, and then every other model that is based on the foundational model, it kind of assumes that is using the data that has been used by the kind of original foundational model. So it doesn't create necessarily, let's say, a succession, and like the developer is not always acknowledging their sources. So the fair use is, again, like a terminology that is used in the US. So it's not something that is used in the Europe or the UK. So the open license there, it's under question, I would say. But again, I think that the AI, the foundational models legislation is a very, very involving area. And I can only recommend to keep an eye. Europeana Foundation, they're doing a good job in addressing, the evolving field through their copyright office. And there's also a provision in the UK to create an AI standards hub. And it would be really good if we can make sure that cultural heritage data rights also have their own say in these discussions. If I answered the questions, good. If not, I can follow up via a comment in the chat.
Yeah, thank you. Yeah, also it's important to highlight, I mean, there's also a lot of indigenous rights regulations, especially on the core principles that should be addressed by Western countries and the global North. So there's a lot of body of legal work behind as well. Another question on the Q&A. Oh, sorry, I think, well, I wonder if awareness of limitations of digital data is an area of research for responsible data. So I think that could be for both of you, but probably you want to take it first, Ana Maria.
Sorry, I missed this one because I I was reading the comment that Martin posted on the chat. Can you just please repeat, Javier, for me?
Yes, sorry, no problem. So if the awareness of the limitations of what data can do, of digital data, is an area that is pertaining to research for responsible data.
The limitations of?
Yeah, so I'll just read it again, sorry.
Yeah.
I wonder if awareness of limitations of digital data is an area of research for responsible data.
Yeah, really good point. It kind of gets us to this really nice area of critical data studies, I guess. So yeah, I think that yeah, we can discuss limitation of digital data, you know, from many aspects. But it's true that yeah, digital data has limitations, but has also specific characteristics. I think that is, yeah, definitely, yeah, an area to address through the responsible data. I'm not sure like how to respond because it's such a vague question, to be honest. So yeah, but I think that this field of critical data studies is really evolving, and yeah, limitation of digital data, for example, can address questions, for example, of collection digital data, of creating digital data, of storing digital data, or for reusing digital data, like the protocols that we're doing this job, the processes that we're following, the values that sits behind all these processes and these practices. So I think it's a very comprehensive field, comprehensive discussion to have about the digital data and the limitations of digital data. And of course, we're speaking about digital data in cultural heritage field. Cultural heritage data is tangible and intangible data, which has also its own limitations. So I think it's like the ecosystem of data is quite complicated, to be honest. And with digital data, things just get even more complicated. Yeah, not easier for sure.
Yeah, and I think, for example, so one question that I have related to that as well, so is what you were mentioning about that neutrality of the data, and so it's not only the data, but it's also the technologies are not neutral as well, either. So yeah, so how do you envision this, the idea that even the tools that we use are designed, created, and made for an audience, for the global North? So first of all, what is the influence of technology within this social machine? Not only technology as a computational system, but also, let's say, text as a technology, text as a colonialist imposition, as well as other type of computational tools. And then perhaps we can connect it to Foteini's of how then we translate these technologies and tools through a blockchain, if it's possible. So, Ana Maria, I don't know, or whoever wants to take it first.
Yeah, I want to hear also Foteini's point, but I just quickly mentioned that, yeah, obviously, I mean, as I tried to show, through our positionality aware framework, we try to address this kind of hidden parameters within the processes, the tools, the models that we create, that technology is not neutral, data is not neutral. When we make use of data or of technical platforms or tools or methods, we need to acknowledge let's say, the positionality, the concepts that we bring with us, and that's something that often gets unnoticed, but I think that's really important for us to bring it to the forefront and to at least acknowledge it and declare it as SADS. I think that the second step is try to address it in a more efficient way. But I think it's really important for us to first of all acknowledge that this is it. But yeah, Foteini, I would like to hear also your idea on this.
Yeah, this is very interesting, and I mean, Anna Maria, is very interesting the work that you do. I'm a little bit familiar because on Sloane Lab, I mean, there have been relevant discussions. We don't, I'm not entirely sure, but I mean, we are talking about those subjects. I mean, this whole question, I think, Javier, goes back to the big, topic of the medium is the message. If the medium is the message, which is always very interesting, and there's no black or white answer. I agree that to everything that we do, there is, some sort of our own biases, how we place the menus. People think from left to right, but that's not applicable to all countries, the heat maps are designed, but the heat maps of our websites indicate, we are primarily thinking everybody kind of speaks our language, reads the way we read. I think the beauty, perhaps, I mean, as I mentioned, there are a lot of risks from blockchain, but perhaps the beauty of such a rather raw technology is that it is, very raw. So it's like a blank sheet of paper, and most, inventions there, like we talked about today, IPFS or even blockchains, are driven by open source communities. Yeah, these open source communities have their own biases as well. I'm not sure entirely whether the distribution of all those contributors is, all around the globe, but essentially these are tools that are problem driven. They're like, what is the problem? And the problem is that, I want to transact, and I'm in a country, we see kind of significant blockchain adoption in countries like that have suffered a lot from sanctions. So the blockchain blockchains really took off there, and these countries are, quite ahead of the curve in adoption because they had this problem. They were the citizens there were really struggling to transact internationally. And so these are tools driven to solve particular problems, and they are quite raw, and this in itself, I think, has kind of like an honesty in it. But obviously, the problem there is that, as I mentioned, where there is no oversight, there is, fertile ground for fraudulent use. So these kind of bare bones technologies are also, prime. And that's why, we see a lot of scams, a lot of this, a lot of that, until kind of, the technology matures to be able to provide those Web 2.0 type of safeguards. And I think what Anna Maria is doing is kind of like the top level, but perhaps what we are discussing today about positionality should kind of now be part of the practice, really, For open source projects, it's more or less obvious, you can go on and see who are the top contributors of the IPFS repository. I can go and check now. Nobody's documenting it, but at least it's out there for everyone to see. For the Ethereum blockchain, again, it's an open source repository. People can go and see who are the most active contributors, But so I think the transparency is what kind of helps the blockchain kind of makes it perhaps slightly easier to do these types of researches than from private companies, but even from GLAM institutions. Yeah. Yeah.
Yeah, perfect. Anna Maria, you want to say something?
Yeah, I was just really kind of motivated by the answer that Foteini gave, because I think that that's the very point, I guess, on this raw technologies that Foteini presented, but also on the kind of like innovative methods that AI, for example, is promising for GLAM institutions. So I think that this very nature of raw technology, or like methods that are in development, so that's not fixed, and yeah, so that's kind of work in progress, if I may say so. So I think it gives us the opportunity to create, some sort of commons, let's say. So we can all, let's say, contribute, and we can somehow shape the field and shape, let's say, the behaviors, the ethics. So it's something that is not fixed and we need to follow the rules. It's something that we are all active members, and we are also active contributors. So it's also upon us to make this work for good. And I think that's also really, to just link it also to the point that I made about responsible data literacy. I think that's something that we need to highlight it, in a TaNC level as well, that it's really important to highlight that it's not about only creating the technical infrastructure and finding this particular technical model to set and connect the collections in a way that is groundbreaking from a technical point of view. But it's really important, to invest in the human resources and in the, let's say, digital literacy of all people involved. So it's really important to create these communities of practice and embed in them this awareness of digital responsible data literacy, data ethics, this idea of having awareness towards our own choices, the tools that we're choosing. So
Hashtag social machines. Well, we just ran out of time. We don't have any more questions, so we did answer all of the questions. So you have 1 more minute to the audience if you want to post any question on the Q&A